In this video, we will look at those inequalities that have special cases for solutions. So we'll just start looking at I first. Our first step is to distribute 2. And just like on the previous example, we want to get those variables on the same side by adding 8a to both sides. But what happens now is that the variable cancels on both sides. So what we're left with is 10 is greater than or equal to 10. Now, just like in the equations, when the variable completely canceled out, we ended up with something that was either always true or never true. So, when is 10 greater than or equal to 10? Well, 10 is always equal to 10, so therefore, A is any real number. A can be anything, and this will always be true. So what that looks like on a number line is we can shade everything all the way to the left, all the way to the right. Stand up, sit down, fight, fight, fight. It's a good one for homecoming week. Anyway, so in these equations, if that variable cancels out, you're going to get down to something that's either always true or never true, and then we will go from there. Always true means that the variable can be any real number. Never true means you have no solution. We'll talk about what that graph looks like also. Now, in the second one, first thing we want to do is combine these like terms, 7m minus m. So 6m minus 5 is greater than 6m plus 7. And then we want to subtract 6m to get the variable on one side. But once again, the variables cancel. They completely cancel, so we are left with negative 5 is greater than 7. So when is negative 5 greater than 7? Well, it is never greater than 7. So therefore, we have no solution. So to graph that solution, all you have is just a blank number line. Put some numbers on it, but there is no shading because there is no solution. Now in the case of k, we subtract 5n from both sides to get the variable on one side. We are left with 9 is less than or equal to negative 1. This is never true. 9 is never less than or equal to negative 1, so therefore we have no solution. And the graph is basically a blank number line. And finally, L, we have 8 plus 6x. We're going to combine those like terms on the right side. Subtract the 6x. So then 8 is greater than or equal to 2, which is always true. So therefore x can be any real number. So this is just like example I, where our number line will have shading everywhere. And those are the inequalities that can have special solutions.